this video, we'll cover the non-numeric data types built into R. By the end of this video, you should know what the primitive non-numeric data types in R actually are, how text data differ from numeric data, and when you might encounter the factor data type when using the tidyverse. The R code that I show in this video is available on Elms, and you may want to take a minute to download it and open it if you'd like to follow along on your own. R is also able to store text data. The way it stores text data is as strings of characters. These are enclosed in either matching single or double quotes. So the example that I have here, hello in double quotation marks, is a string, and also world in single quotation marks is a string. The important thing is they always match. Text data is very different from numeric data. So putting 1576 in quotation marks has R treated as text. Not putting it in quotation marks has it treated as a float. R considers text to be not numbers. So trying to do math on text is going to result in an error, even if the text is exclusively numbers. When you're thinking about converting text to data, R will always convert numbers and logicals into text. True and false will actually become true and false in uppercase. Numbers will be formatted according to your computer's current locale settings. So whether or not you use commas or decimal places as the thousands separator will be taken into account based on how your computer is set up. R can also convert text into other data types. This is really finicky, and you need to get the formatting exactly right or you'll get an error. And I'll show you what this might look like in an example. Let's take a look at using some text data in R. To denote data as text, you either put it in matching double quotes or matching single quotes. So here I have some text data that I put inside of double quotes. R treats it as text data. Likewise, if I use single quotes, R will also treat that as text data. And you can see it doesn't matter which I use, R is always going to put those inside of double quotes whenever it returns them. Now, why would you use single quotes versus double quotes? It depends on the content of the text that you're trying to use. So if you have an apostrophe in your text, maybe you'd like to use double quotes instead, so R doesn't confuse the apostrophe with a single quote. And that's what I have here. R will treat that as a string, but also you might have double quotes in your data. And if you have double quotes, then you can use the single quote, so again, R doesn't get confused. Now you notice R always uses double quotes to denote the start and end of text data. So because I have double quotes inside of this string, it uses a special character, the backslash, to tell me that those double quotes inside of my text are actually inside of the text and not something else. We'll talk about this much more when we dive into text data in detail. A very important thing to understand about text in R is that it is not a number. So, for example, I might think about adding 45 to 12, and I could just type that into R, and I get the result 57. But if I put 45 and 12 in quotation marks, R thinks of those not as numbers, but as text. And when that's the case, normal mathematical operations don't work on those numbers. So here I've done that. I type 45 plus 12 in quotation marks, and what R tells me is I'm trying to provide non-numeric arguments to a binary operator, which means I'm attempting to do math on text. If I'd like to do math on those textual numbers, I would have to convert them to numeric data first. R also has a data type for arbitrary categorical data called a factor. So these are useful when your data take a few discrete but non-numeric values. And what R does with a factor is it actually stores your data as integers, but includes a map that tells R what each value represents. How does this map work? So let's say you were storing data that just includes the 4 cardinal directions on the map, north, east, south, and west. R might define a factor where it maps 1 to north, 2 to east, 3 to south, and 4 to west. This is the mapping that underlies the factor. R is only storing the numbers, and then the mapping that turns those numbers back into the text. Those numbers are called the factor values, and the text, north, east, south, and so on, are called the factor labels. Why do we have this factor data type when we can just store text? Importantly, factors can save on the memory required to store information. As opposed to saving long pieces of text, you're just saving numbers. Memory is not the constraint that it used to be in computing. For example, the computer that I use now has 16,000 times more memory than the computer I had when I was an undergraduate. That's a lot more memory to do things, and it means I'm not as concerned about conserving memory when I'm doing analyses. The fact is, factors can be confusing and lead to some weird results. R will gladly treat your factors as numbers, even when the labels are text. And it doesn't make a lot of sense, in the example that I gave you before, if you took north plus east and the result was south. So factors aren't obsolete, but they have limited usefulness to compare to where we were 10 years ago. In this class, you're actually going to encounter factors most often if you use the base R file readers as opposed to the tidyverse file readers that I'll show you how to use. If you use the tidyverse, you'll only ever see a factor if you explicitly ask R to make one. Also, converting factors to other data types is tricky. Using as character will convert a factor into the text value that it represents. Using add integer on a numeric value will actually return the underlying value, not the factor label that you want to convert into a number. So again, this is why I say you can get some very weird results when using factors in R. R has a number of other built-in data types. In a future video, I'll talk about a data type called vectors. There are also lists that are collections of data that you can refer to by name. R also has support for a variety of complex data types in objects, and packages can provide new object data types. At this point, you should have a good overview of the various data types that are available to you in base R.